Question 1. Three resistors are in parallel with each other. If their resistances are 4 ohms, 6 ohms, and 12 ohms, what is their effective resistance? Now, because of how resistors that are in parallel work, we can tell right away that the total resistance is going to be less than 4 ohms, right? Adding resistors in parallel decreases the effective resistance. The equation that we use is this, of course. 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. And remember that we get this equation from the fact that the total current is going to be the sum of the currents through each resistors, right? What we need to do is combine that with Ohm's law and the fact that the voltage drop across each resistor is the same. Substituting in the numbers, we have 1/4 plus 1/6 plus 1/12. And this gives us 30 over 60, or 1/2. So if 1 over R total equals 1/2, well, R total is going to have to be 2 ohms. So this is our answer. Question 2, similar question. Three resistors are in parallel with each other. Their resistances are 3 ohms, 6 ohms, and 8 ohms. What is their effective resistance? Well, once again, we can tell right away that it's going to be less than 3 ohms. So using the same equation, 1 over R total equals 1 over R1 plus 1 over R2 and so on, we just substitute the numbers, 3 ohms, 6 ohms, 8 ohms, and add them all together. The lowest common multiple is 24, and so adding the fractions together we get 15 on 24, which is the same as 5 over 8 if we divide the top and the bottom by 3. So now we have this equation. 1 over R total equals 5 over 8. What this means is that R total will equal this upside down. We've turned both sides of the equation upside down, and so we end up with R total equals 8 over 5, right? So 8 over 5 ohms is often written as 1.6 ohms. Question 3. Two resistors are in parallel. The first resistor has a resistance of 7 ohms. The second has an unknown resistance. What can you say about the effective resistance of the pair of resistors? Even if we don't know the second resistor at all, we know that the total resistance of two resistors in parallel is smaller than either one of the resistors. So even if we know nothing about the second resistor, we must be able to say that the total resistance will be less than 7 ohms, because the total resistance will be less than the resistance of either one. Part B. What can you say about their effective resistance if the second resistor draws more current than the first one? Now, if the second resistor draws more current, it means that it has a lower resistance than the first resistor. That is, the resistance of the second resistor will be less than 7 ohms. So what can we say about the total resistance? Well, let's look for a moment at what would happen if the second resistor was exactly 7 ohms. Using our equation, 1 over R total would equal 1 over 7 plus 1 over 7, which equals, of course, 2 over 7. Flipping this upside down, the total resistance would equal 7 over 2, or 3.5 ohms. Now, if the second resistor has a resistance of less than 7 ohms, that means that the total resistance will be less than 3.5. And so that's what we write for our answer. The second resistor has a resistance of less than 7 ohms, so the total resistance must be less than 7 over 2, that is 3.5 ohms. If the second resistor drew less current than the first, then we would know that the total resistance of the circuit would be in between 3.5 and 7. Question 4. Two resistors are in parallel. The first resistor has a resistance of 2 ohms. The second has an unknown resistance, and the effective resistance of the pair of resistors is 1.2 ohms. So to solve this, we need to do some algebra. We know that 1 over R total equals 1 over R1 plus 1 over R2. R total is 1.2 ohms. R1 is 2 ohms. we want to rearrange the equation so that R2 is the subject of the equation. 1 over R2 equals 1 over R total minus 1 over R1. That's just rearranging this first equation. That gives us 1 over 1.2 minus 1 over 2. Now, 1.2 is the same as, that's right, 6 over 5. So 1 over 1.2 is going to equal 5 over 6, right? Now we have 5 over 6 minus 1/2, which is the same as minus 3/6, right? And now that we have the same denominator, we can make that, that subtraction, which gives us simply 2 over 6. But that's not the simplest form we can get it. 1 over 3 is even simpler. So our equation now says that 1 over R2 equals 1 over 3. And therefore R2 equals 3 ohms. We can see right away that we would expect R2 to be more than 2 ohms, because if it was exactly 2 ohms, then the total resistance would be 1 ohm. And because it's more than that, R2 must be more than R1. Question 5. A 150 ohm light bulb is connected to a 9 volt power supply. Find the current through the bulb. That should be easy enough, right? Ohm's law. I equals V on R, which is 9 over 150, which gives us a current of 0.06 amps, or 60 milliamps. Part B. If an identical light bulb is connected in parallel with the first, find the current drawn from the power supply. So to answer this question, what we want to do is find the total resistance of the pair of bulbs. If we know the total resistance of the circuit, we can figure out the total current being drawn from the power supply. So R total will be the reciprocal of 1 over 150 plus 1 over 150. This gives us 2 over 150, or 1 over 75. Right? So R total is 75 ohms. I equals V on R. V is going to be 9 volts, and R is only going to be 75 ohms this time. So our answer is 9 over 75, or 0.12 amps, twice as much current as when we only had one bulb. So the more resistors we have in parallel with each other, the less the total resistance of the circuit, and the more current we draw from the power source. So that's the end of the questions. We've figured out how to calculate the total resistance of resistors in parallel. It's going to be less than any of the individual resistors. And we've learned how the voltage drop and current through each one can be calculated.